Transformations with quadratic functions. Okay? On our calculators, we want to turn them on and press the home button. Let's start a new document. Okay? No, we don't want to save our old document. We want to start a new graph. Because what we want to be able to do is we want to be able to put this function right up here, this equation, into our y equals and look at its table. Okay? So I already have my equation line down here at the bottom, so I can put in 2 times the quantity x minus 3 squared plus 4. Now I can see a picture of the graph and that's all fine and good. I really don't care so much about the actual graph right now as I do for the table, because they asked me to fill in this table right here, right? We could go to menu and find the table that way, but do you remember the shortcut to getting to the table if you're in a graph? Control T. Everybody see that? So let's fill in our table. What do you see? When x is 1, y is 12. When x is 2, y is. When x is 3, y is 4. When x is 4, y is 6. When x is 5. And when x is 6, 22. T. Control T opens up a table for you. Okay? Next, simplify the function by squaring, distributing, and collecting like terms. Okay? So if this was my original function, why do they have it written like this? What do they want here? What does it mean to have x minus 3 squared? X minus 3 times x minus 3. Okay? Okay so far? Now we have to use the distributive property. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is positive 9. So let's gather our like terms. These two middle terms are like, aren't they? Okay? So I have x squared minus 6x plus 9. Well, what do I do with this 2? I distribute because it's a multiplier, right? So 2 times x squared is 2x squared. 2 times negative 6x is negative 12x. 2 times 9 is 18. It's okay. Now we can combine these two terms. Okay? 2x squared minus 12x plus 22. Any ideas what's going to happen if I put that equation right here into my calculator for f of 2? Go highlight the table. You got to highlight the table, click on the table, and then press Control T and the table will go away. I think I said highlight the table. I meant highlight the graph. Sorry. Nolan, why do you think it's going to be the same thing? It's the same equation, just in a different form? Okay. So when I go back to hit Control T and look at my table, what do you notice about my y values? They are the same. Did we expect that? Yes, we did. Okay? In fact, we're hoping those are the same, aren't we? Okay? So, these equations are both examples of what? Quadratic functions. Very good. And why are they both examples of quadratic? How do you know that? A number is being squared, right? Okay? So, and there's no more higher exponents than that. The squared is the highest, okay? So more importantly, these equations show the two special forms of these types of functions. You're going to need to know both of these forms, okay? The standard form of an equation, does anybody remember that? Y equals ax squared plus bx plus c. That's when a quadratic is in its simplified form. Okay? What about vertex form? I'm not sure if you've ever seen vertex form. You saw standard form in Algebra 1. Okay? But I don't know which one of these two would show up on a like a standardized test, like an SAT or ACT. So we have to be prepared for both of them. Okay? Vertex form is this. Y equals a times x minus h squared plus k. Okay? Now, I'm hoping that you remember some of this from yesterday, because we did do some investigation yesterday so that today we could actually work on learning what was going on. Okay? When we have an a, when we have a multiplier out there in front, what kind of transformation does that cause? What? Okay. Any idea where you might look if you don't know? How about like right here? You could look on your notes from yesterday, yeah. What does an A cause? A compression or a stretch, right? The only difference is, what if A is a negative? What does that cause? Causes a reflection, okay? Then what if a number is being added on the outside of the squared term? What happens if a number is being added or subtracted on the outside? What kind of transformation does that cause? Yeah, it's a vertical, right? We go either, what directions? Up or down. So the number on the outside moves up or down. What about the number on the inside? Horizontal, left or right, correct? You may want to refer back to this in a minute when we get going, okay? But here's the thing about the vertex form of a quadratic, okay? The vertex is easy to find. Now that seems logical to me, that if we're going to call something the vertex form, that we should be able to find the vertex. And guess what? It's true. The vertex is HK. It's the number on the inside and the number on the outside. That's the vertex. Okay? Turn the page. There's 6 things we need to do on each graph here, or on each equation here, excuse me. First thing I want you to do is be able to tell me if there's a reflection over the x-axis. How can we tell if there's a reflection over the x-axis? If it's a negative, right? If there's a negative multiplier. The next thing you have to be able to do is tell me if there's a vertical shift. What causes a vertical shift? Yeah, thank you. If you don't remember, thank you for looking back. What causes a vertical shift? Which letter? The K, right? The K causes a vertical shift. So we're going to write ourselves a little note here. That's the K. How are we going to remember that? Vertical, like a K. Vertical. So what causes a horizontal shift? H, like the word horizontal starts with a H? Oh my gosh. Coincidence. Identify any vertical stretch or compression. What causes a vertical stretch or compression? The A, the first letter, And determine the standard form. That's what we did here up here at the top, just so you know. Okay, that's how we're going to get standard form. So let's go ahead and get started on number 1. Oh, the last thing is sketching a graph, but we'll get there. Okay, let's start on number 1. Here's the equation given for number 1. Is there a reflection over the x-axis? How do you know that there's not a reflection over the x-axis? There's not a negative multiplier. So we're going to write our answer in Spanish. No. Is there a vertical shift? What causes a vertical shift? The number on the outside, right? The K. Is there a vertical shift? Where? So We don't write plus 4 though. What do we write? What direction is it going? Up. So we write up 4. I'm sorry, I don't know how to say up in Spanish. Nobody does either? Okay, so we're probably in the clear? No. What about C? Horizontal shift. Is there a horizontal shift? The H, the number inside. Okay, so which way is it moving? Left or right? And we want it to move right to. Anybody know how to say right in Spanish? Pardon? Are you just making up words? Great. So what about D? Is there any vertical stretch or compression? Is there a multiplier in front of the parentheses? No. So there's none, right? So we're going to write this in Spanish. Nada. Spanish is not required. It's okay. Determine the standard form of a quadratic equation. Guys, that's not enough room for me to write. I'm going to take out my trusty piece of notebook paper. Number 1. Y equals x minus 2 squared plus 4. Okay? Well, remember that x minus 2 squared is really x minus 2 times x minus 2, correct? Yes or no? Yes. Okay. So I want to distribute here and get x times x. What is x times x? Good. What's x times negative 2? Negative 2x. What's negative 2 times x? And what's negative 2 times negative 2? Plus 4. Then we also have this 4, that's part of the original problem that we have to just bring on down, right? Now I can combine my like terms. Y equals x squared minus 4x plus 8. Any questions about that? I want to go ahead and transfer my answer to my answer page. Okay? And I do need to keep this with it so I have my work. Does that make sense? Okay, now let's graph it. So earlier they're like, okay, let's get our calculators. I don't wanna. You could get your calculator out and graph it. Transfer the table to your paper, plot the points from the table, draw the line, and I would be halfway through number 3 already. Okay? Sometimes our calculator is helpful, sometimes it makes things longer. Okay? So watch this for me. Where does my vertex of my parabola move? Didn't I just tell myself? My vertex moves up 4 and right 2. So my vertex is right there. Okay so far? Did it change shape? Is there a multiplier that causes a stretch or compression, or does it stay the same shape? Stays the same shape. So the original shape of my parent function says over 1 up 1, because 1 squared is 1. Over 2 up 4, because 2 squared is 4. Over 3 up 9, because 3 squared is 9. Does that make sense? If I stayed the same shape, can't I just start at my vertex and go over 1 up 1 and over 2 up 4? Does that make sense? And since I know parabolas are symmetric, I can go over 1 to the left and up 1, over 2 to the right, or excuse me, over 2 to the left and up 4, and have my parabola right there for me? Does that make sense? Good. Any questions on that? Anyone else have an opinion besides Nolan? No? Okay, thanks, Nolan. So, let's look at number 2. Yes. Is there a reflection? What causes a reflection? So is there one? Wait, does it need a thing? What's that thing called? An accent? Does it need one? Okay. It does? So I don't want it to be if. I want it to be yes. Just like... Okay. Thank you. Does it go that way or does it go the other way? Or does it matter? Okay. It's good? You're the one that told me I didn't need one. Okay. What about B? Does it have a vertical shift? Is there a number on the outside? So how will this shift? Down 5? So wait, we're talking in English and writing in Spanish and then talking about math? So we're being trilingual today. Good for us. We are scholars, definitely. What about C? Is there a number on the inside? So how is it moving? Right 4? Are you sure? Pretty positive because I'm writing in pen and I'm already writing it? Or because you really knew? Oh, okay. Okay. What about D? Is there a vertical stretch or compression? What about E? Determine the standard form. How do we do this again? Do I need to do it slow or do you want me to just do it and you check your work? Slow? Okay. Y equals a negative times x minus 4 times x minus 4. Everybody understand why it's x minus 4 times x minus 4? Because this one is x minus 4 squared. Anything squared is just that times itself. Okay. So I need to distribute those two parentheses. X times x. X squared. X times negative 4. Negative 4x. This negative 4 times this x. Negative 4x. And negative 4 times negative 4. 16, right? Now, that's all still in parentheses because I'm not done with it yet, is it? It's different than last time. Last time everything was done, there was no multiplier. This time there's a multiplier, so we have to simplify inside first. Y equals negative x squared minus 8x plus 16. Okay so far? Y equals negative x squared plus 8x minus 16 minus 5. Where in the world did that come from? It's like I distributed a negative 1 to each term, isn't it? Okay. So last but not least, I combine my like terms. Y equals negative x squared plus 8x minus 21. I got it right? Okay, thank you. Okay. Negative x squared plus 8x plus minus 21. Okay, so far? Where is my vertex? Down 5. Right 4. So it's right there, right? So earlier in another class we talked about, does it matter what order I do that in? What if I went right 4 first and then down 5? Oh. Does it matter what order I do that in? No. Okay. Now, something's different here. What's different? Is there a reflection? Yeah. So this time I can't go over 1 up 1, but can I go over 1 down 1? Can I go over 2 down 4? And why did I go over 2 down 4? Because 2 squared is 4, right? And I know parabolas are symmetric, so I can do the same thing on the other side. And then I have my parabola. Questions? Okay. So what about number 3? Does it have a reflection? Anyone? You think yes? What makes it have a reflection? Has to be a negative. So is there a reflection? No. Is there a vertical shift? What direction? Vertical is the K, and the K is outside, down 4. Is there a horizontal shift? Horizontal is H. H is inside. Which direction am I moving? Left 3. And is there any stretch or compression? Stretch or compression is caused by A. Is there a multiplier in front? So, is it a stretch or compression? How do you know it's a stretch? Because it's greater than 1, it's a stretch. Greater than 1 is a stretch. What's a compression? Less than 1 and greater than 0. Very good. Very good. Okay. Determine the standard form. Y equals 2 times the quantity x plus 3 squared minus 4. So I say y equals 2 times x plus 3 times x plus 3 minus 4. Distribute x squared plus 3x plus 3x plus 9. Okay, so far? What can I do with the like terms? Combine them. X squared plus 6x plus 9. What do I do with the 2? Distribute here, here, and here to each term. So y equals 2x squared plus 12x plus 18, and then minus 4. So y equals 2x squared plus 12x plus 14. Any questions about that? Now we got to graph it. Where's my vertex? Down 4, left 3. So this one's different. How is this one different? It has a multiplier, right? It's a stretch. So normally we could go over 1, up 1, because 1 squared is 1, right? But this time we got to go over 1 and up 1 times 2, which is 2, absolutely. We got to multiply that multiplier times the number it normally is. So normally I go over 2 and up 4, but this time I'm going to go over 2 up 4 times 2, which is 8. Normally I go over 3 and up 9, but this time I'm going to go over 3 and up 9 times 2, which is 18. Now if I do that, it's going to put me somewhere up here, so I don't want to do that. But I know my parabola is symmetric, so I can do the same thing on the other side. And then draw my parabola. Okay so far? Please turn over to number 5. Okay, please turn over to number 5. Can you do this backwards now? Y equals a times x minus h squared plus k. I'm going to finish this for the video, so if you want to stay you can, but I'm going to finish it for the video and I'll have it on my blog. Okay? The vertex is over to the right 3, so that's going to be x plus 3. Excuse me, minus 3. And then it went up 1, 2, 3, 4, 5. So that's up 5. That's the k. That's the vertical shift. And I can tell by the shape of this that it's regular parent function shape. So there's not a multiplier. However, it is upside down, so I do have to have a negative. Okay? Okay? So look at 6. Y equals a times x minus h squared plus k. My vertex moved 1, 2, 3, 4, 5 to the left, so it's going to be x plus 5. And then it moved down 1, 2, 3, 4, down 4. It does have a different shape. It's a little wider, so you know I have a multiplier. And I went over 1 and up something that I can't tell. I went over 2 and up 2, it's half as high as I'd normally go, so my multiplier is going to be a half. Okay? Let me do 4 really quickly since we have time. Well, since I have time. The other 6. Okay? So, does it have a reflection? No. There's no reflection. B, is there a vertical shift? There's no number on the outside, so there's no vertical shift. C, horizontal shift. Is there a number on the inside, the H? Yes, it's a plus 5, or so we're going to say left 5. Is there a multiplier on the outside? Is there a vertical stretch or compression? Yes, since this number is between 0 and 1, this is a compression by a factor of a half. And then E, so we say y equals a half times x plus 5 squared. So that's a half times x plus 5 times x plus 5. Distribute here first. X squared plus 5x plus 5x plus 25. And that's all being multiplied by a half. So I have y equals half x squared. Oh, that's 10x, excuse me. Oh, we didn't combine it like terms, that's why. That's 10x. So if I multiply that term by a half, I get 5x. And then 25 times a half is 25 halves. That's the equation that goes here. 1 half x squared plus 5x plus 25 halves. Now if you put 12 and a half here, that's fine. But when we go to graph it, where's our vertex? Our vertex is only left 5. Is it parent function shaped? No, because we have a compression by a factor of a half. So from here, instead of going over 1 and up 1, we're going to go over 1 and up half of what we normally would. Instead of going over 2 and up 4, we're going to go over 2 and up half of what we normally would, which would be half of 4, which would be 2. Instead of going over 3 and up 9, we'd go half of that, which is 4 1/2. I know parabolas are symmetric, So I can do the same thing on the other side. And then draw my parabola. Okay? I hope you have a great day. Do problems 1 through 6, these problems, for homework.